Hello everyone, let's continue our discussion on the 4G and 5G cellular networks. Okay, so these are the solution for wide area mobile internet. Before we already talked about the Wi-Fi, which provides the connectivity, wireless connectivity on the local area networks. So this 4G and 5G provides the connectivity to wide area mobile internet. And widespread and of deployment and use, more mobile broadband connected devices than fixed broadband connected devices, 5 to 1 in 2019, and availability 90% of time in Korea. So basically, availability in terms of when it's the network availability, okay, throughout the years. So which is when we talk about the server, SLA is not that high, but it's already considered high, 97% and 90% in US. And the transmission rate is up to 100 Mbps, which is quite high for the wireless networks. Okay, and even if we see the 5G, even up to several gigabytes per second. Okay, and then it's the standards are defined by a third generation partnership project or 3GPP. And for the 4G, the standard is called LTE or long term evolution standard. Okay, so I'm not going to talk, in details on this. We can see some similarities and differences to the wired networks. First, we have the edge and core distinctions, but both belong to the same carrier. So basically, edge and core, uh, we have the edge networks in the wired network and the core networks in the wired networks. But then in the cellular networks, the edge and core are belong to the same carriers, unlike um, uh, uh, in the wired networks. Okay, the core network can belong to different carriers or different telco companies. Global cellular networks can also be considered as a network of networks. Now it's not just ISPs, the wired internet network ISPs, but also this global cellular networks becomes also the network of networks, part of this ISPs. Widespread of use of protocols, the same as the same protocols are used again in the cellular networks: HTTP, DNS, TCP, UDP, IPNet, and so on and so forth. Because since 4G, we are using full IP, okay, all IP stack, and there's interconnected to wired internet, okay. Now the differences from the wired networks, of course, like the link layers is different because now we are using a wireless link, okay, and the mobility as the first class service. Unlike in the wired networks, we that do not support the mobility. Now, in 4G, 5G, or cellular networks in general, the mobility is the most important part. And we introduced the user identity via the SIM card. In the in the wired networks, we don't have like a device identity. Anyone can use any devices. There is no really like user identity. But now in the it's not just the 4G 5G in cell networks. The identity is really attached to the device. Okay, so and the business model, users are subscribe to a solar networks and a strong notion of home networks. We'll talk about that later, especially when we talk about the mobility. And there's a global access. Okay, so it needs the authentication infrastructure. So basically, like this global access means like let's say we are the user of one telco operators in Indonesia, and we are traveling to abroad. Then we can use telco networks from different carriers abroad. Uh, with some inter-carrier settlements, provided that those local carrier and in Indonesia and telco carriers in the country that we are visiting have some kind of agreements, and it needs some authentication. Okay, authentication between the local carrier in Indonesia and the telco carrier in the foreign countries. Okay, now let's talk about the elements of 4G LTE net architectures, starting from the mobile device. Okay, so mobile device can be anything, basically, anything that has 4G interface. It can be a tablet, laptop, smartphone, even IoT. And then it has 60-bit international mobile subscriber identity. This is unique, and this only belongs, when, like, some, I don't know, I don't remember whether it is, like, I think it's last year. Indonesia has given, if any all the devices, mobile devices that enters Indonesia has to be registered. The IMSI of the all the mobile devices that enter Indonesia has to be registered, and otherwise it is blocked to the by the telco operators. And also, this is stored in a SIM card. Okay, that's why it is, when one device has double SIMs, then it has to have this double IMSI also. Okay, now, the jargon, or the term that is used in 4G is called the user equipment, or UE. So just different naming, but basically the same thing. But of course, like, with different functionalities. Okay, now we have also base stations. Base stations in 4G is called E-Node-B. So edge of care networks manage wireless radio resources and a mobile device in its coverage area. And then it coordinates device authentication with other elements. So basically, yeah, all devices, mobile devices, has to be, I mean, when it wants to communicate with the 4G network, it has to be authenticated. And this base station, or E-Node-B, is the first layer of authentication. Okay, similar to Wi-Fi access point, but active role in user mobility. Yeah, in Wi-Fi, the access point does not have, active role in mobility. So, for example, like, in E-Node-B or base station, when the user is about to leave one base station and then going to the next, the neighboring base station, then the base station will set up this the handoff, in place of the mobile device or user equipment. Right. So, it also coordinates with nearly with the adjacent base stations to optimize the radio use. Okay, so actually, perhaps in the later first technology of Wi-Fi technology, we can also have this Wi-Fi controllers, and Wi-Fi controllers can, base stations can coordinate to optimize the uses of wireless capacity. All right, so now we have this home subscriber service, or HSS, which stores info about the mobile devices, for which the HSS networks is their home network. So basically, this home networks means that, the user is belongs to one telco operators. When we are subscribed to one telco operators, or when we buy a SIM card from one telco operators, then this is our home networks. So let's say when it travels around roaming to other networks, then this HSS will be contacted. Okay, and this has to know the latest location of that user now. Okay, works with MME for authentication, device authentication. Okay, so because the MME has to know who is the what is the home network of this device, and what is the current location of this device. All right, now, this serving gateway and PDN gateway, packet data network gateway. As I said before, we can make the analogy between this gateway, MSC gateway, serving MSC and MSC gateway with the routers. So now, in this LTE, this basically the PDN gateway is really the gateway to the internet. Okay, so we can have only one gateway to the internet, and there's serving gateway, which can be, any routers in the networks. Um, um, this can act as the serving gateway. Okay, so this is in the data path from mobile to the internet. And then the P gateway or PDN gateway, gateway to the mobile cellular networks, so to the internet. And looks like any other internet gateway router provides net services. Okay, so it also provides net services. And the other routers, as the other routers or the serving gateways, it is using extensive tunneling extensively. Okay, so we'll talk about this tunneling later. Okay, especially this is used for the mobility. Okay, support the mobility and the LTE. Okay, and finally, there is a mobility management entity or MME. Okay, there are several functions of MME. It manages device authentication, both from device to network and network to device, or this is called the mutual authentication, which coordinating with the mobile home network HSS. Okay, and then mobile device management. For example, handover between cells. So when let's say these mobile users are moving from one base station, one E node B to another E node B. So the handover is okay. So first, it can be initiated by the old E node B. So the E node B has to communicate with the mobile management entity, mobility management entity, okay, to inform about the handover, and then this yeah, later this handover will occur, and the path is moved from the old E node B to the new E node B. It also used for the tracking and paging device location. So basically, to detect the current location of the device of the mobile users or user equipment, LTE uses this paging, okay, paging signal or tracking, okay, and it also set up the tunneling or path from mobile to mobile device to the PDN gateway, okay, or P gateway. Okay, so this is the central entity that set up the tunneling. All right, so more about the tunneling will be explained in the next video. Let's stop at the moment here, and let's see you again in the next video.